We are stoked to have Alec and Duchemin judging your performances, but we also have two others, Aaron and Kat. All of them will be our judges for tonight's performances, computational performances by all of you. Super excited to have you. Marco has a number of incredible announcements, and so I am hyped to hear everything that he's about to say. Marco. Yeah.
Yes, so this is the third hackathon we do. It started as a really small thing, as I was saying, and this has been an experiment over the last couple of times. But we want to make this a little bit bigger. We want to bring more people. The first thing we want to ask all of you is, you know anyone that is amazing at hacking and building, please invite them to the next hackathon. We're going to plan, we're going to send probably the dates out there when we want to do it. But we want to keep doing this because I think it's very exciting to see people just building stuff, coding things, and just getting together and just doing all this amazing work that everyone has been doing. By the way, side stories, I just love everyone seeing like hacking around the house. That was super cool. Having the conversations with Alec and Young and everyone here, that was super nice. Also like funny stories, like I think someone dropped a laptop in water and like there was anyway, like amazing guys, thank you for coming. So we're gonna get started with the panel. So we have joining us the panel is gonna be Kat, as you guys know from Index Ventures. Woo! We have Erin. Woo! Come on guys. Erin. She's joining us from NVIDIA, and by the way, the price of the RTX 4090 is confirmed. She was the one who made it possible, which is amazing.
It'll still take 3 weeks though, but
it's coming. This is amazing. Like, again, it's in super high demand. So thank you.
Yeah.
Obviously, you guys know Alec and Young are going to be joining us for the panel. I don't think we can have such a good panel with you, right? So how do we get started? So should we?
Okay. The intention is that everyone with a project of substance will have a presentation of some sort, and we will basically go person by person. Is there any incredibly excited and intrepid soul that would like to present first and foremost? Okay, I will present first and foremost.
Okay, there you go.
Okay, so I think that we are going to live in a phenomenal future where every word that is coming out of my mouth right now will be accessible to myself and to everybody who is interested in what we're saying here at the Whisper Hackathon in real time whenever we want it. And so I set up a pipeline that allows you to turn a bit of information from Whisper into text that can be searched via neural networks, doing what's called dense retrieval, looking for the sentences, paragraphs, and phrases that are similar in meaning to whatever it is that you're reading or writing. And so what you see here is a sidebar on the right-hand side, which is doing real-time semantic search over Lex Friedman's data. So if you know the AI podcast by Lex Friedman, all of those podcasts have been transcribed by Whisper and are here to read. So if I jump into Udaya Pearl, an expert in causality's particular interview, we'll basically be able to see that as I highlight text, the system does semantic retrievals that discover information from other people who are working in the field. So in the case of Udaya Pearl, we jump to this line that says, faking intelligence is intelligent because it is not easy to fake. And if we want to find every example of faking intelligence across the Lex Friedman podcast, we can see Richard Heyer here saying, if I can fool you that I'm intelligent, then that's a good test of intelligence. And we can jump into the podcast transcript, specifically seeing this line. If you're talking to two people, and the test is saying who has an I or high Q, it's an interesting test. Maybe charisma can be useful in convincing the other. You only allow these conversations. So I can jump into basically every example of what is a fake test. And here you're talking about faking reading books. Here it's talking about fooling people when you're tweeting or writing blog posts. I would never do this. There's real intelligence behind it. But basically it's a comprehensive semantic search system. Now, if I'm curious, if I say I go to Twitter, always dangerous, and I guess I have a newsfeed eradicator, so we'll see if we can find a tweet. Maybe I'll use a tweet of my own. Basically, I can open this exact same sidebar on Twitter, and It's a bunch of generative love stuff. But actually, I wonder what on the Lex Friedman podcast is there to be said about generative love? And so if I highlight that content, I can see, Samba describing love persisting in some form, the experience of love as being something that can be cultivated. And so wherever I am on the internet, I can be jumping into the relevant parts of Lex Friedman's podcast. And so this is an example of sort of real-time semantic retrieval over whispered data. Welcome to Alma.
Questions?
Yep.
So when you talk about semantics, do you go one lattice above? How, like Levenstein distance? Like what do you use to grow, like to find the matches?
So here, this is actually using a BERT-style dual encoder model that basically creates an embedding, and in that embedding space, I do cosine similarity. There's some magic over the embeddings, but it's not that special. So you can basically do approximate nearest neighbor search with a system like Scan or FICE or Annoy. And so in basically no time, discover all of the vectors that are very close by the vector that you have just highlighted or typed, and serve that to user.
More questions?
How do you get it to start indexing another form of media? Is it just Lex Friedman's podcasts so far, or is it?
So yeah, actually I added a feature to this pipeline. So basically, it used to just be a text pipeline of folders, files, websites. So you could type in any website and it'll upload the website, and then Drive. So it'll grab all of the text docs on Drive. But now if you put an audio file into the file upload, it will trigger the Whisper pipeline, which I used to upload the Lex Friedman data set. Yeah. Awesome.
So is this the company you're working on now then?
Yeah, exactly. So I added a pipeline to my existing company's product. Yeah.
Very cool. So I mean, of course, when you're talking about a topic, there's going to be a whole bunch of viewpoints on that particular topic. How are you thinking about curating the knowledge that is along the thread that I want, right? So for example, I don't know, if I'm about rockets or something, I might be searching for rockets where I want to know how to build them, versus other people might be searching for videos on them exploding, right? How do you actually curate the right string of what I want?
So basically, the data set that you're retrieving from here, it's Lex Friedman, but it could be, Ignite, the book that Elon, the book that Elon read when he was building SpaceX.
Yeah.
So if I jump into the Elon Musk data set, I will start to get content from Liftoff, right? As opposed to content from YouTube or another data source. So basically, you curate the data set. So if you upload a YouTube channel, which is now possible with the YouTube to Whisper pipeline, that is all about rockets blowing up. All of your retrievals, when you select that data set, will be about rockets blowing up.
Cool.
Yeah. Cool. Welcome to the future of semantic audio to speech semantic search. I think that with this and a number of other tools, we're going to live in an incredible future very quickly. So, thank you.
We can go
Who wants
next.
to go next?
Oh my god.
Showing
Yo,
this.
it's this one.
Okay,
Yeah.
so starting off with intention. So what's the intention here that we wanted to work on? So starting off with some Stanford lectures. In this case, this is Bio 150, which is human behavioral biology. It's a neuroscience course, and we wanted to take classes. In this case, a Stanford class, and be able to take topics from those classes and be able to extract concepts and put it into a knowledge graph. And ideally, over time, there would be multiple classes in this knowledge graph, and each class would represent a path of nodes and edges throughout this graph. So we started with one lecture, which is this introduction to human behavioral biology. It's about 1 hour long. The next step was we used Whisper to transcribe that lecture. So here's the lecture, Bio 150, and it's pretty good. Actually, I took out in the beginning, it spelled Stanford wrong. It was Stanford, but yeah, it's pretty good. Then afterwards, and there's also some cases here of a bunch of ones, I don't know why that happened. But overall, it's been pretty good. It captured deeply technical neuroscience terms very well. And so we took this transcript, chunked it into segments, and then ran it through GPT-3 to get to topic cluster. And through that process, was able to get this, a bunch of nodes, a bunch of edges, and the edges are chronologically based, so they map concepts based on the time that the topic came up within the lecture, and then we mapped it using D3. So this is okay. So there you go. So this is Bio 150, human behavioral biology, and then the first node that showed up was evaluative feedback. There are paths from here, it's a directed graph, so there's a path from evaluative feedback to all of the rest of the nodes. Over time, would like to not only have one course or one lecture of a course, but the whole course, and then multiple courses, be in this graph. And I would say probably one of the challenges would be for concepts that come up that are similar, being able to combine those concepts and also be able to have descriptions that are easily explainable for people to understand.
Can you give a deeper explanation? So, GPT-3 prompt, what do the edges mean? And can you show us one thing you learned from this concept graph, or one meaningful anything?
Yeah. Do you guys want to take some of the questions?
Talking about GPT-3 specifically, maybe.
Or
what that process looked like.
The GPT-3 part was after we tried some other clustering mechanisms like LDA or thinking about k-means, we realized that perhaps GPT-3 is the easier way to go because it not only gives you the cluster, it also gives you a name for the cluster as opposed to just a centroid. So we just ran a prompt through GPT-3 and formatted the answers, or I guess provided a answer format for the answer. Then the answer generated was very consistent. Then we formatted the answer and created all these notes.
What do the edges mean?
Oh yeah, okay, so each of the edges represent, in this case it's chronologically based, so based on when the concept shows up within the video, so right now every node has one edge directed towards the node and one edge directed away. So say in point 0, there's, let's see here. So the first thing that's talked about is evaluative feedback, then depth of processing, then timing. And so evaluative feedback has a edge pointing to depth of processing, depth then has one pointing to priming, and so on and so forth. So I think long term it makes sense to also do it based on topic and subtopics.
So something that is of my personal interest is if we can actually use this to go if I want to learn more about something on that graph, I can figure out, okay, these actual 5 other things can all feed into this one particular topic and make me understand it in these different dimensions. So I think something that comes up in my research a lot is something I don't actually know what the next interesting path is. So if it can help me rabbit hole, I would appreciate that a lot. And I guess this is more of an ask than something I learned, but if you have ideas on how to do this, I'd be personally really interested in them.
Questions?
Because you're doing this
chronologically, how do you envision having the graph next to the video? So when people are watching the video, if they don't understand how a concept that has just been explained is related to the concept they learned about before, and there's this thing of zone of proximal development. So maybe they learn a word, but they don't, or a concept, but they don't know how it's related to things they know before. So your graph could help with that.
Yeah, that's a great idea.
Any more questions?
Yeah. This is quite interesting, but currently, just to clarify, it's just this one long sequence in terms of the nodes being connected to each other. Okay, I think what would be even more interesting, and this would be really interesting, is if you could build a comprehensive knowledge graph and have very nice relationships between edges, like, I don't know, like, what's it called? Like, a Shiba is a dog, for example, or like it just builds it up, and for every single video, it has its own like knowledge graph where the premises build up to like, you know, higher order concepts. And I think over the course of the course, like just being able to like see and have this like almost Chrome extension in Paint, where you just see a knowledge graph of everything in the video. I think it'd be cool, and you're like, oh, I actually don't understand this foundational concept. Click on it, you can see all the times it was highlighted in the video, and then you can click on it, and I don't know, I think it'd be interesting.
That's a great suggestion. We kind of talked about that. There could be like different levels of clustering that we could do, but right now, because we're just doing one lecture video from one course, there is no repetition of concepts, and there is kind of no hierarchy in this. So yeah, we didn't have time to dive into it, but yeah, great suggestion.
Any more questions? Also from the panel, no questions?
What's one thing you learned from the knowledge graph?
Not sure we got that far yet, Jeremy.
But
I think like on a more meta level of the process of going through this project is figuring out how the lecture videos interact with the entire course. It would interact with, like, say, an entire university's curriculum. And so thinking about that, one thing, as we mentioned, when we tried topic clustering using other methods, it was pretty like, well, I think it was pretty fast to tell when we tried doing it that it was would need to be human reviewed in order for it to be like applicable, which is why we went with this chronological order method. And so I guess like the learning is how might we topic cluster in a way that is like human readable and easily traversable by humans. So yeah.
Yeah, I think it's secretly very deep because human brains function on association over time, and you have a heavy and learning rule for your knowledge graph generation. So potential. Okay, thanks a lot.
Thank you.
Nice job, guys.
Who wants to go next? There you go.
So the problem is that public speaking is kind of one of the consistently really high skills that people want to get good at, right? But also, paradoxically, people don't want to do public speaking. It's like one of the top 3 fears of Americans. So how do you actually improve, how do you like public speaking without having to do all these reps in public, right? So we kind of want to build this, in your smartphone, real-time feedback, so you can be more charismatic or something like that. So what can we do today? We want to be able to do filler word detection, just like earlier, and also repeated words, anything that's mumbled or incoherent words. For example, let's say the transcription says, "Is it finally time for dinner?" We can probably reason as humans that you probably meant to say time. So that's what we have today.
And now on to a little bit about more about how this works. We use OpenAI Whisper to obtain as accurate of a transcript as we can from the raw audio data provided as an MP3, M4A, or other audio format. Once we have accomplished that, we can use Python algorithms to detect a certain set of filler words, so as just mentioned earlier, stuff like or, ah. And we also use other Python algorithms to determine when phrases are being repeated in short time spans across a speech, which is something that we also obviously want to avoid as public speakers. Once we've done that, we move on to some more complicated processing, where we use a transformer-based network in conjunction with word-to-vec embeddings and cosine similarity to determine if Whisper has been looking or has determined an incorrect word that we assume that the human most likely didn't want to put there. Okay, and for our demo, it does take a while to run, so we tried on 2 MP3s. The first one is a speech by Obama. We note here that Obama, obviously an excellent public speaker, our former president, has used no filler words in our list. He used 0 repeated words in this list, which is another mark for an excellent public speaker. And of all his words, only 5.6 were unrecognized by Whisper AI, and we can put up at least part of that down machine translation or other non-human errors. Now, on the other hand, at the other end of the spectrum, we have Little Pump of Gucci Gang fame. As you can imagine, This didn't perform quite so well. We did still find that we had 0 filler words, which is more likely an issue with our filler word dictionary than anything else. We did, however, find that the Gucci Gang lyrics do, in fact, include a significant amount of repeated words, as you might imagine, as well as a significant amount of unrecognized words. You can see examples here, and also here, if you're not convinced. So, what are some applications of AI? Obviously, an easy one is general public use. If you're practicing for a presentation or for like maybe a graduation commencement, something like that, AI is perfect for you. You can use it in the classrooms, both as a student as a teacher. As a teacher, we might want to recognize when our lessons are a little bit unclear or we're not as confident, we might want to seem to students. On the student end, we might want to diagnose topics that we are ourselves unfamiliar with. We can use it in political preparation, so for instance, if you're preparing for a debate or a rally, and finally, something that you guys might all be interested in, feedback on business meetings and pitches and stuff like that.
So what's next? So obviously can be used to save our presentation, but that's also lots of other interesting things on the line. So speech quality is kind of dynamic, right? As you know, people maybe gain confidence as they speak, right? There's some momentum going, and maybe this latter half of their pitch is extremely coherent and great. So we want to be able to kind of adapt to the speaker, and perhaps maybe over time, right? Maybe the latter half at certain timestamps, you can basically give feedback that's localized there. And also segmented kind of analysis of different speech sections, like I mentioned before, and also topic analysis. For example, maybe you have a 5-minute pitch, right? You want to spend 1 minute talking about your introduction, maybe 3 minutes on some sort of technical details, right? And then the last minute on, let's say, like applications. So we're going to kind of like basically bunch a lot of things, these things together, so that one, you can do analysis on the time spent, right? And also perhaps maybe you use filler words on a topic that you're less familiar with. So highlighting that is super useful, and also word choice. And lastly, we want to do this in real time, but also there's just some technical limitations as well. So cool, that's on AI. Woo! Woo!
Questions? For the transformer mask fill, can you talk a little bit more about the details of how that was done or what was going on there?
Absolutely, yeah. So basically what we do is we take a subset of about like each target word in the sequence. So for example, if the sequence was "it's raining cats and dogs," we replace each word with a mask. We then see what the transformer output predicts to be the top maybe 10 or so words to be placed there. We compare it to what the Whisper algorithm placed there, and we use cosine similarity to see if they match to a reasonable degree. If they don't match at all, then we flag that word as very suspicious and we add it to the list.
Yeah. And is this using BERT or what's the
yes,
model? Okay, cool. Thanks. Awesome. Also, some of the filler word detection might be a problem with Whisper. Whisper sometimes cleans up audio. So
yeah, we noticed that. Yeah. So sometimes we got like the and the us in the transcript, and other times we didn't, and it's definitely something inconsistent.
You can try prompt engineering it, where if you, because it can condition on the previous text segment, if you start with like a demo segment that's like got an and an ah, it might keep it going. But yeah, this is unfortunately. Don't blame yourselves for that. That's on us.
Another thing we were considering with that regard is comparing Whisper AI's output to a different transcript generator that doesn't filter out that stuff and seeing what the differences there are.
Yeah, an off-the-shelf like C2C way to vect 2.0 kind of system should be able to give you those filler words.
All right. No other questions? All right, then we're good.
Cool, thank you.
Questions? That's it? Round of applause.
Hello, everybody. So I was up here earlier today, basically talking about how customer service sucks, and even though chatbots and automated, conversational AI has been around for a while, we're still waiting on hold, and customer service turns over at 40% year over year. And so if you imagine all the infrastructure required to have, for sometimes companies like Bank of America, 50,000 call center reps sitting in an office fully equipped with all the technology to then have a layer of management above them and another layer and like 12 more management layers, everyone to basically do what? Have an army of human beings sitting there interpreting a customer request and mapping that onto a preset flow. Companies already know what their customers can do and can't do. Customers are not coming to companies trying to do things. You're not calling Home Depot or Pizza Hut trying to book a new flight or reschedule your flight. And so for my demo, using our technology, I have basically crafted the world's smoothest flight reschedule. And I'm going to demo it live over phone right now. All right, so I'm just resetting my conversation, and I'm just going to go ahead and give this number a call. I'm going to show it after, sort of the back end of how the architecture that we used to build this, and some of the lessons I learned along the way, and some of the breakthroughs that I had today of things I hadn't even considered. Let me try that again. The live demo is real. Hello. Okay, great. Bear with me 1 second. Okay, apologies, and this is like super ironic and hypocritical, but I need to come back into the flow at a later stage and check what's happening here. So I worked on the test right before, but I will be back. Thank you.
Oh yeah. So I made this application. It's basically a note-taking app that has also semantic search. So you can record anything from a conversation to like your own thoughts. And it's gonna run the recording on the device with Whisper. So that's what I just said. And then, of course, there's already ways to like take notes, but usually you cannot really search them because you don't remember the words that you use. For example, today I recorded a bunch of the most funny conversations of this at this event. Of course, I asked before, and I remember it was Mark that was telling me about a mixologist, robotic mixologist. And yeah, it's not funny because there is not the exact word in the notes that I took, but I can connect to my machine where I'm running a semantic search simple engine. And I hit search, and it's probably gonna find the sentence where Marcus said that he was talking about the mixer robot. Or, I don't know what else we talked about. Remember at some point we were talking about food, and I can look at all my audio notes that are about food. And there's something about pizza, and then like a mistake. That's it.
Any questions for Francesco?
What is the search?
Is this the sentence transformers? It's basically embedding and then tracking and flipping by distance.
Is Whisper running on your phone?
Yeah.
What framework did you use?
Small. I just used I want to try Caramel just because I come from there. Then I found someone just ported it already to like C++ that works very, very well. I don't think it's like super optimal. I think it can get much faster than already is now. Yeah, that one. What?
You said Whisper.cpp?
Yes, that one. I think it gets much faster than that. It's I checked the code. They use like loops and dot products. If you do if you get to the neural engine, it's going to get much faster. The main problem I think is, hopefully, I really hope that it gets in the operating system Whispers, because even the tiny version is way better than the others. The main problem I think will be, the large models, they take a lot of disk space. So for mobile applications, I think that the speed is there, like they can do it, they're powerful enough. The problem is fitting the model on the device right now. So if you can come up with like a smaller version but with more flops, I think that could be the best for the phone.
So what was the framework name?
I just found it on GitHub. Somebody just wrote it manually in C++, like layer by layer. Yeah, but if I didn't find that, I would have used Caramel, and that's it.
So my name's Praneet and this is Alex, and we have two other people that we work with on this project, Arib and Omar. And what we basically did was we didn't use Whisper. We just used GPT-3 for our ML project. And essentially what it is it's like a group chat with like, I guess like anybody you want advice from, right? So like for our demo purposes, we created a group chat with like Mark Cuban, Elon, Steve Jobs, and like Bill Gates, etc. Sarah Blakely as well, personal hero. And we didn't hook it up completely, so we just had like a front end, but then we have the model as well, where, so like we asked it like, should I raise money, right? And so we had this group chat response where like Sarah gave a response, and then Sam Altman like kind of went off of Sarah's response and like added to it. And so, yeah, zoom in, yes. Can you read that? Aroused? Okay. And then like we also tried like some like things that were not startup related, and saw if like, these are like business people that are in our group chat, so we wanted to see like, how they responded. We said like, this real quick?
So the idea is like you put your number on the site, and then Elon or whoever the group leader texts you like, hey, we're gonna make a group chat with Sarah, Bill, Mark, etc. And you give it, you text kind of a question you have, and then they kind of go off on a conversation, riff off of each other, and there you have a group chat with your heroes.
Yeah, so that's the response link breakups.
There's a lot of similarities in the response.
Yeah, we tried to. So what we basically did was like we didn't do this in like the proper way. The proper way would be like we train each person on like their corpus, right? So like stuff that they've said in the past and did it that way. What we essentially did was we did prompt engineering. So if we like put into the prompt like this person said this based on the summary of the conversation so far. So it's just like a hacky way to do it. Yeah. So like future directions would be to like exactly like try to make it more fine-tuned to each person, so it's like more unique.
Yeah. We are storing the whole context of the conversation though, and then reusing that, using that in the prompts.
Yeah.
So
that's
our
hackathon prompt.
Yeah, the advisors. Thank you.
No more questions for them?
How do I sign up?
Right now it's up. It's at advisors.webflow.io. We'll put it on a domain soon. Yeah, we'll put it in the chat. Yeah.
Thank you, everyone.
Who's next?
All right. What's up, gamers? We have over here Diffusion Craft. So this may look like an ordinary Minecraft world, but if you fly out, these are all blocks, by the way, in Minecraft. But that over there was Drake playing in the NBA. But you can see we have a world. And any single person, you guys can also join this right now. Go to diffusioncraft.com. You can also find our IP address on our website. But anyone can join and they can just add to this beautiful canvas that is this wonderful world. And we actually started this at the first hackathon for Stable Diffusion, and we implemented this. And we'll get to like where we're headed next. I think immediately though is what we're gonna do in the coming hackathons. This is like an ongoing hack. Oh, that's a bit. You weren't supposed to see that. But right now, I've lately seen some really cool stuff with Stable Diffusion 1.5. There's pretty good outpainting now, and I'm thinking that, okay, what if instead of having all of these different, boundaries being separate images, what if you stored a single image and you had everything outpaint together? Okay, that was Anna, your demo with the professor. That was like him as a psycho clown. Anyways, so that's another thing that we're headed to. And Brennan's gonna explain how we did our original hack.
Sure. So the way this works is we just the initial 2D implementation, we take images from Stable Diffusion, downscale them, approximate them using the nearest neighbor colors, for Minecraft blocks, and we have a certain palette of Minecraft blocks that we can use, and we just place those in the world in an image. Currently, we're limited to 128 by 128 resolution. That's easy to change, and it works asynchronously so that it doesn't lock up the server when you run a command. So yeah, any of you can log in if you want to. Diffusioncraft.com, type /imagine, and you can generate anything. So the next stage of this, and I feel like the most obvious progression from this, is to start doing this in 3D, which is what we are working on in this hackathon. We have not completed it, but we have made some good progress. So here.
Yeah, so we were actually implementing the generations from Dream Fusion, which is a text to 3D diffusion model. We got some of its outputs. Over here you can see it's a very cute corgi with a nurse hat, and we voxelized it, you can see, in a format that we can port into Minecraft. And what we're about to do, Brendan, you want to plug in your laptop? Is now we're working and we're basically finalizing the generation so that these can come into your Minecraft world. I think this is going to be quite powerful and interesting because I think it'd be awesome to expose dozens of 7-year-olds just like the ability to generate anything. Now, right now the tech isn't here, so we're actually kind of like approximating so that, okay, let's build the 3D generation side in a Minecraft server first, and then when the models get good enough that I can perform imprints on them within a couple seconds, dude, that's gonna be nuts. Right now it's a couple hours because it's pretty novel, but we're getting there. And you can see we tried to port it in. I had a bit of problems with kind of dealing with the data file format for 3D, but yeah, this is our current generation.
The biggest technical problem at the moment is loading the 3D models that contain colors, which turns out to be really hard because this is not very well documented. So this is currently just the mesh, no colors, but it's going to be very, very straightforward to port this over.
Diffusion class.
Questions for our students?
Question. There are lots of efforts to generate 3D artifacts for 3D printing. So if you look at the 3D printing repos, you could actually get already 3D models that you could downsample. Have you looked at STL files in Thingiverse or other repos like that?
Yeah, so I mean, currently what we're doing at the moment is, well, the answer is yes, because currently I've loaded this corgi model into the mod. So yes, absolutely, we can load 3D models. I guess the idea is that we want to do the full pipeline. But I mean, yeah. So on the Minecraft side, yeah, this could very easily be ported over to just load any 3D model, and actually that would probably be a good feature.
Cool.
Yeah.
Questions?
Oh yeah, adding on to that, so I actually looked into implementing that. Now the problem is that the APIs for these like 3D model websites are obviously like really bad, but how I imagine is that you do like search and then you get like the best results and then you just generate it. Unfortunately, the APIs don't exist, and I don't want to scrape stuff. Hey.
Hey, so how reasonable or feasible do you think it is to be able to get a 3D object to actually be animated and move in a vectorized position?
Well, so we were told by Ajay Jain from Dream Fusion that currently it costs $5 per model.
Oh yeah.
So maybe I guess currently you could do it if you want to pay maybe $1,000 a minute or so. I don't know. Is that coming?
I mean, it's basically just like getting the individual frames, which and then like converting it into Minecraft, and you can load in animations per se. I mean, Minecraft runs really fast, but yeah, in terms of like generating 3D models that move, it's a bit pricey.
I don't think the 7-year-olds can afford that.
Maybe some. Bitcoin.
This is so sick. Congrats.
Yeah, so awesome.
Thanks, guys. Stay tuned. Diffusiontop.com. We're going to launch it very shortly.
I use Whisper to create a natural language interface.
Something like that.
Series A slide.
All right. Hey everyone. And pretty excited to have like such high quality caliber people. So thank you for doing this voice focused hackathon. So I'm going to present a bit of sort of like my work over the last years. And I thought it was kind of like a good connection to kind of think about the future of voice as well. So the first thing is like, who are those people on the screen? So this is me when I was 12 and my sister when she was 10. Actually, no, sorry, younger than that, then I'm 8. This is the day where I started fighting for accessibility. So I was born basically in a deaf family. So my sister is deaf, my mother and my father as well. Sign language is my first language. So I've always been in the middle of language, like lost in translation, basically, trying to make sure that my parents, have full accessibility. So I would go with them to the doctor, at the bank. And when you think about sort of technologies that come out and that are really exciting over the last years, we've seen like AI applied to detect against cancer by just like taking photos of an eye. We've seen AI used to kind of try to avoid victims during car accidents. But when you think about speech recognition and speech sciences, it's been so far Alexa to help me order pizzas faster. It's been Siri to help me not open too long, liking too much time like a web browser. So I think, and that's the hope also with kind of Whisper sort of like coming out and building more open source models, that maybe we can bring a bit more impact in this field of AI. So just wanted to sort of like introduce you to one of the problems that we have with deaf African people. So 450 million people on Earth today, every day, will not be able to participate to a meeting like this. Because people around them just speak, have conversations, it's a social time, and they rely on lip reading. And since COVID, it's gotten even worse, right? Like with masks, it's just very hard to follow. So sometimes it's a hit or miss, sometimes you can follow, sometimes the person has a mustache, an accent, it makes it really hard to understand. So we basically sort of coded Ava, which I'm gonna show you right now, appearing on the screen, as the first, I would say, live transcription technology that works everywhere as a tool for a deaf or African person that adds something that's very important, which is speaker identification. So we've all seen speech recognition, and today we've gotten introduced to the Whisper way of thinking. But we basically have really focused on speaker identification, which is another category, which is really around telling who is saying what. So I'm going to invite a guinea pig to come. I don't know, Sigil, if you want to try saying something in the phone.
Hello, I would like to buy some Bitcoin. Do you have Bitcoin on you? I would love to trade some US dollars for the Bitcoin. Thank you so much.
All right. So you see the different colors that we have on top and in the bottom?
Yes, I do see them. But I want some Bitcoin.
I can give you some Bitcoin if you're being a good demo guest. So I'm gonna name you right now. I'm gonna add your name. It basically, when I train the model on the fly, I can then have a conversation just keep going and it will recognize your voice.
Really? I don't believe you. Oh my God, wait, is it gonna recognize me? Oh, it does. Look at that.
So it has switched both of it. So your voice and my voice. So, so that's a bit the demo here. A few things about how this works in the backend. So what you don't see is like this has been trained on thousands and thousands of conversations, group conversations, that deaf people have had over the last 3 or 4 years. So they went to meetings like this with inviting other people with their own phones, connected multiple microphones together, and this allowed us to basically have in real time 3 signals. 1, which is the tone of voice, 2, the distance to the microphone, and 3, the angle compared to the microphone as well. So that meant that we had each time like 1 or 2 different sort of measures to be able to like tell in real time the precision on the speaker and train an accurate database. So if you have a conversation with 4 phones like this, you can then train a situation with just one phone on a more accurate and labeled data set with 4 phones at the same time. So it's basically kind of a gradient descent, and we used it and sort of labeled it with professional scribes. So this is an example of like trying to sort of go a bit deeper, and it started as a hackathon actually. We started as a startup weekend. We did a glove that was sort of trying to translate sign language in 48 hours, and kind of like iterated to be more that diarization project. So the one thing I want to leave you with, and that's the project called AVA, as audiovisual accessibility, is just the fact that this is a project that we call basically speech recognition, like led by the deaf and for the deaf. And what's interesting is that when you look at the history of communication technologies, like the telephone, like brain-machine interface, the internet, or the SMS, those are things we are excited about and we're using every day. Not yet the brain-machine interface, but that should come. The fun things about it is that each time at the beginning of it, there was a deaf or hard of hearing person. Either the inventor was deaf or hard of hearing, like the internet. Vint Cerf was hard of hearing himself, and he had trouble understanding, phone call conversations. Or for the SMS, it was a team, a Finnish engineering team, who basically met a deaf person, was waiting for 30 minutes in front of a pizzeria. And they basically had to say, hey, why are you not just calling them? And he's like, hey, I can't use the phone. So they invented the SMS as a short text message service. So necessity is the mother of invention. Keep it in mind. That helps you find sort of like pain points and users and interesting projects directions as well. So thank you for listening. And go AI, go voice, and let's just try to make AI for good as well. Okay. AVA, as audio visual accessibility, and probably in the future access as well.
So that was like super fast. Was that using Whisper's model for the transcription?
No, so presently we're using Google Speech API for the transcription, and we're using our own diarization engine, which is a neural network, like basically on top of this blended. We did look at Whisper.ai last week, as I was telling them. Our benchmark kind of indicated like to be close, not always like above the existing thing, but we might try to fine tune it. We'll be emailing with them and see if we can beat the Google Speech, which is the big thing.
Well, one more question. So for the diarization engine, is the data largely from open source online sources?
No, all internal data that we created, so based on mobile phones, desktop computer app as well, of the last 5 years.
Oh wow, so like existing users.
Sorry?
Like from existing users?
Yeah, about 100,000 monthly active users.
That's crazy.
And all that.
I can just yell. I'm curious, what's the most significant parameter when you're trying to identify a speaker? What's the most significant parameter when you're trying to identify a speaker? Like, is it
the most significant what?
Parameter, like is it
parameter,
intonation? Yeah, like the intonation. Is it like speech, tonality? Like what is it exactly?
Yeah, so really the 3 dimensions that matter are the tone. So like when you close your eyes, you can already sort of tell apart Braden from my voice. Yeah. So there's like in the girl's voice, the male's voice, like this is the tone. The second thing is the angle at which it hits the device. So when you're on just one phone, it's using both the tone and parameters that we have recorded about your voice. But when you use a second phone, which is kind of our main implementation for a group of 4 or 5 people, just the tone is not enough because of a lot of noise that happens. So what we use is like the angle and the position, the way it hits the clock. So basically, each phone has either 1 microphone or 2 microphones. So we applied what we've learned with 2 phones back to the 2 microphone phone. And we call it like stereo diarization.
Does speech rate have a significant impact, or?
No, well, we haven't used it. We haven't like made a feature around this, so we can look at it into it. I do think that probably will be captured some way, but no, I don't think we've used it, and that's a good point.
I have a question about brain-computer interfaces. Yeah. It's wrong in my sense that there will no longer be deaf people in 10 to 15 years because a brain-computer interface will be able to process the language coming out of my mouth, represent it in a way that's amenable to a system inside of their brain that learns to recognize signals sent through perhaps a scent-based BCI or a lace-based BCI. And so I'm wondering, do you partner with existing state-of-the-art brain-computer interface companies, and do you know what their sort of data frontier looks like?
They're
so specifically, do they have data streams that are amenable to this kind of tool, and like what are their agendas for writing to, or like sending information as opposed to like having information come out of the person. Because I've seen people tweet
This is good.
but I want to know what it looks like on their roadmap to have a deaf person say receive information from the external.
Okay, so a long story short is like, no, I don't have insights to share about this specific area, but other insights are interesting. So one, the brain-machine interface started with a cochlear implant. So it started in like 1954, and it's been basically 50 years of data of like operating people and trying to sort of fix hearing loss through this. Two, it might be that in the next 15 years, we are able to avoid like some hearing loss using cochlear implant or a form of brain-machine interface. However, I think just the cost of the operation, the fact that there's 450 million people who are like in places and countries, so it's like the future is not evenly distributed. We want a solution that works for the next 30 years. And one thing to say about this is that people have talked about the Apple Watch, Google Glasses, and it's obviously like a good implementation. The reality is consumer adoption is not even there. So we still are seeing the impact of mobile just transforming like every single thing. So before it comes to AR and comes to like watches, it's even like longer time scale. So we're kind of like projecting ourselves towards this, so you can see that future. But I think it's going to take a lot of time for this to happen. We might just like hack very quickly like a device or a way to do AR, for example, here. But before it like gets used from every single deaf person, it's going to take way more time. Now I think we'll be partnering probably with AR companies before cochlear implant or brain-machine interface companies. But it's fascinating. Okay.
Awesome.
Alright, so I just have a really simple. So I was working on trying to get Whisper working with processing and streaming audio source, and it broke when I used it. Let's try to redo that. Send SSH tone. Okay, that's running, that's good. That should be running. Hey, that works. Whew. Let's make this clearer. Alright, so right now, all this does is it continuously takes the audio stream from my microphone on the computer, and it sends to a server that has Whisper running. I have a VAD that tries to chop up the audio stream, and then when it detects, come on, there we go. And when it detects sort of silence or breaks, then it would send the audio segment over to Whisper to transcribe. Cool. And that's pretty much it. And right now this one, it's using just the Whisper base model, the small model. It should work with multi-language. I suddenly don't know how to speak in another language.
Wait.
Go for it.
早上好，中国！现在我有冰淇淋，我很喜欢冰淇淋，但是，Does that work? Oh my god! Again? Does anyone else want to try? All right.
早上好，这里是广播电视台。老师们、同学们，大家早上好。It's not very accurate. Let me try.
Also, speaking it up from the speaker, by the way. So the mic and the situation is weird, but like the audio quality is going to be super good.
No one saw that.
We're cutting that out.
Yeah, not bad. What a good time. Questions? Any questions?
Can you share your front end code? I want to do some stable diffusion real-time generation with you.
Yeah, sure.
Just put it in the chat. Yeah. Any other questions?
What breaks the connection?
I think I was just. That second part, I'm not sure. I'll have to look at the. It could always just be internet issues.
What was hard? What was hard? Is any part of this?
I think I don't really know how to code in JavaScript. So
front end.
Basically, no front end, and also pretty much crash course in making this demo client. Nope.
Any other questions?
Any other questions?
Sweet.
Yeah, thank you.
Cool. Awesome. Cool. Okay, so I'm just gonna give a quick intro. So actually, I did this last Sunday, but I want to do. There was actually a story behind this. So I did this last Sunday, which was just basically a very simple email. Like you can just put any YouTube video. It will send you basically a PDF or a Word document with timestamps, so you can just specifically go into, you can see there, like, you can just click in any of the timestamps over there, and it will send you straight to the YouTube video to that specific time. The reason for that was because obviously there are podcasts that are really long, and you don't want to just listen to the whole thing, and you want to go specifically to a section of the video. And this kind of ignited also like an idea. We started working in another hackathon, an ML hackathon, to basically just make a really cool search engine for podcasts on video or any podcast. And that's what we're going to show you really quick.
So if any of you know the My First Million podcast, that's like kind of the podcast that we used for our demo. We took like the 10 most popular podcast episodes and like used Marco's model to like transcribe it and get timestamps. And it's not showing. Oh, yeah. And so like you can search for a certain phrase.
Sorry.
It'll pull up where in the podcast that was said, and then you can click on the link, and it'll take you to that part. Oh, that's not it. There's a 2-second buffer, so like there's context around the phrase. Oh, the audio's not working.
Oh, the audio is just put the mic here.
Oh, yeah.
I love the idea of like your digital media company being acquired and then you have to do
recording another episode. Yeah, look, I got the content. Sorry we were late. We were recording another episode.
Let me redo that.
Let's travel, never looking back. All right. Sorry we were late.
So there it is. That's what I searched for, and it came up in the podcast episode. So yeah, that's our demo.
Eventually, the goal is to do it in all the podcasts out there, like Lex Friedman, MFM, everything. That will be like, obviously a long project, but yeah, that would be like the idea. Questions?
Is the intent to do search this particular podcast, given a podcast, or search the space of all podcasts, or search subsets of podcasts? And yeah, I'm actually curious.
Yeah, I think the current direction we want to take it in is like basically create a search engine for like different podcasts. So like one for My First Million, one for like Lex Fridman's like AI podcast. Yeah, I think like we've had conversations around just doing it for like all podcasts in general. It's just that we don't know how that exactly looks, and like especially for like training time and things of that nature. Like even for like these 10 videos, it took 5 minutes of time to just like transcribe all of them, right? So yeah, we're kind of clear on the direction we'll take. Yeah.
So let's say I have lossy memory and I wasn't quite sure the phrase that was said. Is it like semantic search, or like, let's say on a higher level idea, let's say, right? On like a Streaming podcast, I want to talk about self-supervised learning, and I can search all the topics on self-supervised learning.
Yeah. So right now it's like some really like hacky like JavaScript based like search. There's no like fancy search to it, but I think Actually, after looking at Jeremy's search engine today, I think that's a good direction you want to go in, right? Because that just makes sense. Because you're not always going to remember the exact phrase, right?
Of course.
So yeah.
Also, yes, and so hybrid systems will outperform both in all cases. So
right. Yeah.
Feel free to talk to me about this. Happy to see.
For sure. Thank you.
Hello, we're last but not least. So my name is Steph, and I'm going to be presenting today with Russ about our project Data Teller. We haven't worked on this before, so it's our first step, or what we managed to hack in a few hours this afternoon. And the goal of this project is to actually allow people to become storytellers with data. And the premise is pretty simple. You use natural language, which gets used to generate code, which gets used to create data visualizations. Why do we want to do this? Learning data science is hard, so if you're in a data science lecture or any sort of like tutorials you're doing online, or you hear people talk about graphs and all sorts of data manipulation, it's really hard to understand like some of the concepts. So it would be nice if in real time, like when you're hearing a professor or a YouTuber or a friend talk about data, like how the market is doing or Bitcoin or whatever, to actually be able to visualize what they're saying in real time and have like intuitive visualizations that come along together with the story or with the explanation they're providing. So how do we do this, right? Like how do we go from natural language, use some processing, and actually generate plots that make sense in real time? So let's imagine this scenario. Let's say that I talk to a friend or a colleague and say, most employees in my company leave in the first year. While I'm saying this, this natural language actually gets transformed into code for generating the visualization. And there's an example there. And then we actually get a plot that gets to show like, oh, what's the relationship between the employee's experience and the attrition in my company. So we have like a quick demo that I'm going to demonstrate. And then I'm going to let Russ tell you a bit more about the code generation part. So let's see if this works. Generate a plot of employees' departure in my company. It's not the fastest, but let's hope it works. I haven't used it with the mic and the speaker and all of that. So you can see it did a pretty good job. It also shows me what language is detecting it. These parts don't work yet. I mean, I could get a random image that is using diffusion, but the part that doesn't work yet is the code generation. We didn't manage to plug it into the demo, but we made it work into a local file Python, and I'll let Russ talk a little bit more about this part of how we go to speech to code generation.
So it's not all wired up together, but you can see there what is working. So imagine that the output of the speech is draw correlation between expenses and location. That's one input of the code generation model. Another one is the headers of the data set, so the names of the columns. And then the model generates what you see there, a call into your library, which calls a scatter plot, picking the right columns that you mentioned in the text, right? And you notice that the expenses don't actually correspond to cost. It's a different name, but it sort of found the closest name and generated that column. And for comparison, how does that work with Copilot, which is probably the best code generation tool of this kind today? So I gave Copilot this data set. So it's an array of structs, and it can tell that there is salary and gender in every struct. I wrote the command and it should generate code, but it didn't. It just generated the header of the loop. So that's not great. We would like to do this completely automatically from speech, so no coding required. But Copilot can do it if you add this extra declaration there, or you define the array struct headers with the headers in it. Then the code that it produces actually is impressively correct. But you see, you need to massage the code to get it out. So we would like to do it completely automatically from just speech, completely hidden. That would probably require creating a constrained data visualization library so that there are fewer choices for the code generator to go through. But that's where we are. Questions?
Questions?
No plot fans in the room.
There is a question.
Oh, yeah.
So do you need to already supply it with the data set, or does it also generate the data set itself?
The assumption is that we have the data set.
Yeah, I supply the data set.
Okay, and then it generates the codex code to plot the data.
Yeah.
Okay, nice.
You could use synthetic data if you don't have a data set, so import like synthetic data as well.
Yeah, I think what would be really cool is if they could just search the internet and just get it. It's like,
yeah.
Can you plot like Moore's law? Like, is Moore's law actually dead? And then it gives you a bunch of statistics.
Yeah, so if you convert this into SQL or something in between, have this intermediate step, and then generate plot from,
So
would it be better? So if you, or like, you can compare it to like one of those tools where you could like specify natural language query and then like get a SQL query and then
Right. So that would be strictly harder because you need to do a data transformation, right, before you do it. This would be strictly harder than just visualization.
Yeah, but then like no one has a data set in the first place, right? That's
Right.
part of the problem. Right? You got a giant like warehouse with like all kinds of data.
Right.
And I think the first step is usually the hardest part is like how do you like generate like
And turn it into a nice column data that
Exactly.
relates to this.
Right.
So we do have some results that can do the transformation together with visualization by demonstration, without programming, by demonstration, but not from natural language. I can show you how you would do transformation and visualization by effectively showing one data point and how you plot it and then it generalizes, but I don't know how to do it from natural language.
And for the internet data, the closest thing is I've actually seen people play with this quite a bit. Like when you ask DALL-E to plot the latest, like the last week in the stock market, what it gives you, or if you ask it, it's like the closest thing we have, like querying the internet for doing visualizations, but it wouldn't be usable. It's fun though.
Something simple like open a spreadsheet and then like have a Chrome extension on the right. And a spreadsheet is simple, right? Maybe like 2 columns, and you can say, hey, can you like correlate these 2 things?
So that should work, right? Because if the data is organized into columns and you are referring to correlation,
Right.
and you know what the headers are, I mean, it looks like...
That would be a cool demo actually, having like a Google sheet and then like you saying like, hey, can you like show us the relationship or like express the relationship between these 2 things?
But if you need to transform the data to get it into this nice shape, then that's the extra transformation step that's harder.
Yeah, so I hated grade 10 business, but like if you could like automate kind of like just playing with spreadsheets and just, I mean, I don't want to memorize all the operations and stuff for Google Sheets, but that'd be freaking awesome.
Awesome. Thank you.
Thank you. Awesome. Any more teas? I don't know what is it? Okay. The reprise. Oh yeah, you didn't go back there.
Test. All right, hello everybody. I've got some bad news. At the time I was fixing it, I missed my flight, so I just got to reschedule it here real quick. Okay. just hang tight for a second, chill out.
Hey Will, what can I do for you?
Yeah, hey, I got tied up at a hackathon. I'm gonna need to reschedule my flight.
Got it, not a problem. Hope the hackathon was a good time. Let me see what time the next available time is. While I pull those up, I just want to make sure, if you will, I've sent the code to your phone. What is it?
105898.
Thanks. You're authenticated okay. I have tonight at 11 p.m. or tomorrow at 9 a.m. Which one is best?
Tomorrow morning is fine.
Okay, I'll log in 9 a.m. for you tomorrow. Anything else I can do for you, Will?
No, that's it. Thanks so much.
Okay, well, thanks for being a loyal United Airlines customer.
All right, cool. So this is our platform, and so it's basically like a simple block builder that allows you to go through the flows, like we have here, flow of how can I serve you, authentication, available flight times, reschedule, anything else I can help you with. Obviously very linear. It doesn't, what we're building is the ability to basically after this question of how can I serve you, it comes in, and we are able to customize some features here like, hey, how are we gonna ask this message? How are we gonna acknowledge it if we do not recognize a specific category? This is kind of the secret sauce here because we have categories of, say, rescheduled flight, and that includes the category name as well as the response for if they give a variation of a message of natural language that we put in here. Now, so far up to today, we've had our customers who were applying this in real estate come up with all the variations by themselves. But inside of just being in this environment, I realized that with very simple prompt engineering on GPT-3 and some like being able to give it some different grammatical constraints, it could come in and auto-generate all the variations. So if someone's coming in and saying, wanting to build their own, or an enterprise company doesn't want to have to think and solve for every single grammatical use case, so we can still calculate a distance between my query. It does not have to be an exact fit. And then also Learn GPT-3 has a similarity check as well, like kind of semantic comparison, and we compare it against the glove model that we're currently using. And so we break the sentence when it comes down into its grammatical components and then compare that to this. And so some of the other things that we're adding is the ability to, like say in some other cases, actually redirect this conversation or have an action feature that through an API, this company, you would actually be able to tie this into a backend database to pull the flights and the available times. Obviously for this purpose, for the demo, was very much kind of simplified, and some of these were hard coded. For example, the authentication, that these would be the points in the conversation where you'd actually just tie into a company's systems. So, thank you very much. Any questions?
Is the speech to text all whisper powered?
Yeah, it is not. No, this is, I called up one of my engineers today, and we realized that for the amount of text that we need, as well as like the use case here, we need it to be really quick. And so we just use a baseline Twilio. But as we start to test different cases, like if somebody's walking on the street or in a noisy cafe or an environment or airport, right, we're gonna test all the different text-to-speech as well as speech-to-text models out there to see which ones can perform. And so I'm looking forward to trying out Whisper, but we do not have the capacity to do that today. Yeah.
So here you're grabbing a few entities. Are you able to support entity overfilling where if the user knows exactly what they want, they're able to one-shot it, say, hey, I want a flight for tomorrow morning, versus having to go through the step by step?
So in terms of like a context of booking a flight?
Yeah, so like if the user knows the system well and they come in for the first time, can they give multiple entities at once instead of having to go through a linear flow?
Yeah, totally. So we would come in here and inside this, we would create a category, right? Like where this is a rescheduled flight, and we could create a book flight, and inside of this it would have variations of, hey, I'd like to book a flight, things like that, and it would detect to see if it has the parameters needed to fulfill that query. If not, it would come back and say, got it, what time would you like, or hey, I have these times, where do you want to travel from? So yeah, that's how it gets organized.
Any other questions? Okay, I think we are done with Teams, right?
Okay, I want everyone who is here happy to just give a short 30-second, 3 or 4 sentences. Here's what I did, here's what I thought about, even if you didn't, demo to everybody. So, yeah, what you talked about, conversation you had, anything. Yeah, I'm curious.
I was talking about some downsides of large language models over memorizing things.
Paul?
Yeah, we did demo.
Okay.
It's like.
So we're gonna have also 5 minutes. The panel is gonna go and just chat about the winner. Meanwhile, we would love to hear what Jeremy just said. Any highlights? What you enjoyed doing today? Please just.
I mean, I took it down because I'm like, but Jeremy,
Let's
like,
have some swag songs. I feel like you know everyone.
times more than I prepared, so.
For Index?
Yeah.
Dude, I love Index Venture
Can you go
sock.
out and hand socks out to people?
I will be the sock boy.
Thank you. You're the best.
I'm honored. Really? All right, boy, do I have socks for you.